So today what we're going to do is be graphing all of these functions by hand. So I'm going to have you start off by solving the first 6 on your paper by finding the amplitude and period of all of these. So pause the video, do that, and then once you're done, come back and see if you got the answers right. So here's the amplitude for all of these. They're all sine or cosine, so they all have an amplitude. So for 1 and 2, there is no number, so we put 1 for the amplitude. For 3, 4, 5, and 6, they all have a number out front. You have to make sure to take the absolute value. That's why the amplitude for number 4 is positive 4 and not negative 4. Now for the period for all of them, since they're all sine and cosine, you do 360 divided by b. So if you notice, I have 360 on the top of all of these, and I divided them by whatever's in front of the x, and the circled answers are what the period is. So next we're going to practice how to find amplitude and period by looking at the graph. So I'm going to do number 7 for you, and then you're going to try 8, 9, and 10. So to find the amplitude of these graphs, you're finding the height down to the equilibrium. So how you find that is you go to the very top of any of these curves, so right there, and you draw a line down to the center, and you're trying to find whatever that distance is. So that height is 3 tall, so the amplitude is 3. Now to find period, so we did a couple days ago. So how I do it is I start right there in the center, and I go 1 complete revolution, so 1 up, 1 down, and then I'm back at the beginning right here. And so right there at the axis it says pi, so the period is pi, or you could do 180 degrees, which is the degree conversion. So now you try 8, 9, and 10, and then play the video after you're done to see if you got the answers right. So for number 8, the amplitude from the very top of any of these curves down to the axis, this one is 4. This one from their top down is 2. This one from the very top down is 5. So then the period. So from the from the axis, I start at the very top of the curve, and then to get to the top of the next curve, it's 2 pi, or 360 if you prefer degrees. I want to convert it. So then this one, if I start at the axis, I have to go, it starts in the middle, so I go up 1, up over the mountain, down through the valley, and I arrive at the end, which is 4 pi, or that is 720 degrees. And then last one, I start at the valley, I go up over my mountain, I get back down to the end of my valley, and it is 2 pi, or 360. Remember, if you have any questions, please ask me. So now we're going to start to learn how to sketch these on our own by hand. So these two graphs only have an amplitude and a period. We're going to get into phase shift and vertical shift after this, but we're going to go slowly. So first you want to figure out what the amplitude and period is, like we've been doing. So in this case, the amplitude is 4, because that 4 right there. And then the period is 360 divided by b. b is 1, so 360 degrees for the period. So then how I suggest that you graph these is to first do your amplitude. So remember, amplitude is from the equilibrium. So remember, this is our equilibrium right here, because we're not doing any vertical shift yet. It's 4 tall and 4 low. So that means above the equilibrium it goes 4 up, and it goes 4 down. So then you want to find your period. So the period is 1 revolution. So you're going to start at the axis, and it's going to stop at 360, which is 2 pi. So we're there. So basically I've defined a space where I am going to be drawing. So it's going to be this space right here is where my sine graph is going to go. So then you need to draw it. So a sine graph, you need to know the shapes. That's why you did this on the first day. You drew the sine and cosine graphs. So a sine graph always starts in the middle, goes up, then goes down, and then ends at the middle. That's how a sine graph goes. And then a cosine graph starts at the top, dips down to the very bottom, and ends at the top. So since this is a sine graph, that means it's going to start at the middle at the equilibrium. It's going to go and has to reach to the very top of your amplitude. Then it goes down, and it's got to reach the very bottom of your amplitude, and it ends at the middle. So that is your first one. So then, let's look at this cosine graph. So the amplitude of the cosine graph is 2. And the period is 360 divided by b, so 360. So I start off by defining my amplitude. So that means from the equilibrium down the center, it's 2 high. So I draw a line at 2 above the equilibrium, and I draw a line at 2 below the equilibrium. So this is going to be a shorter graph. So then my period is 360. So we're going to start at the axis, and it's going to end at 360 or 2 pi. So now I have my defined space. So there's the top, there's the bottom, and there are the 2 sides. And since it's a cosine graph, I need to start at the top and end at the top. So cosine graphs start here. Oh, let me do it in blue. Starts at the top, goes all the way to the bottom, and ends at the top. So that's how a cosine graph makes. It's got to span the entire box. It can't be too short. It's got to go from top to bottom. So now what I want you to do is to do 13, 14, 15, and 16. Be careful once you get to 14 and 16 because there is a negative out front. So that means whenever you're drawing it, you're going to have to flip over your graph. So once you have them drawn, go ahead and replay it and see how you do. So for number 2, the amplitude is 2. So that means it's going to be 2 high and 2 low below the equilibrium in the middle. Period is 180. So that means it's always going to start there. 180 is the same thing as pi, so that means it ends there. So then I draw within my box the sine graph. So remember, sine starts in the middle, has a mountain first, crosses through the middle, has a valley, and then ends at the middle. So that is the first one. For the next one, the amplitude is 1. So it's going to be a very small graph. So 1 above, 1 below. Period is 180. So start at the axis. 180 is the same thing as pi, so it ends right there. So it needs to fit in that little box there. And then it is flipped. So usually cosine starts at the top, and since it's flipped now, it's going to start at the bottom. It's going to raise all the way to the top, then end at the bottom. For the next one, the amplitude is 3, so 3 tall, 3 low. Period is 360, so starts here, 360, same thing as 2 pi, so ends there. This one is not flipped, so that means it will start at the top because it's cosine, go all the way down and end at the top. Last one, the amplitude is 2, so 2 high, 2 low. Period is 45, so it's a smaller period. 45 is the same thing as pi over 2, so it can end right there. So I need to squeeze this in there. It is flipped because of that negative sign. So sine, remember, always starts in the middle, and then it has a mountain first, like in number 13 it has a mountain first. So this means since it's flipped, it's going to have the valley first, cross through the middle, and then have the mountain next. So now for 17 through 20, go ahead and find the amplitude, period, phase shift, and vertical shift for each of these like you did yesterday. Do notice that some of these have the D out front, so that 2 right there is actually the D, so that would be the vertical shift. It's just out front instead of behind the back. So go ahead and do that, pause the video, play it, and see if you got the right answers. Go ahead and check your answers and make sure that what you did is right. I think the largest mistake would be the phase shift in number 17. Perhaps you didn't keep change flip, because this is originally 4/1, so when you keep change flip, it'd be 1/4. That's how I got negative pi over 8. Another mistake is some people in number 19 may think that this negative 4 right there is the C, but it is the D because it's not in parentheses. So that's why the vertical shift is negative 4 and there is no phase shift. All right, last slide. This is your actual goal, is to sketch this graph for one entire period for the whole thing, phase shift, vertical shift, everything. So the first thing you want to do is find the amplitude, period, phase shift, and vertical shift. So the amplitude for this first one is 3, because it's before the sine. The period of this one would be 360 divided by 2, so 180. The phase shift for this one would be negative c, so negative pi over 2, divided by b, which is 2. You'd have to keep change flip, the negatives would cancel, and you'd be left with pi over 4, which is the same thing as 45 degrees. So if you like degree conversion, 45 degrees. And then the vertical shift is 1. So then after you do that, I'm going to tell you step by step how I graph it. So you can do a variety of ways, but I think this is the easiest. So down below, write these steps. So the first thing you want to do is to do the vertical shift. You want to draw that, and wherever vertically shifts, you're going to draw your equilibrium. So in this case, the vertical shift is 1. So that means this graph is shifted up 1. So the new equilibrium is going to be right here. So then the second step is you want to do the phase shift. So the phase shift is 45 degrees, or pi over 4. Since it's a positive, it's going to be shifted to the right. So pi over 4 will be right in between the 0 and the pi over 2. So right here. That's our phase shift. So then the next thing you want to do is the period. So remember, the period is how long this graph goes, starting from the starting point. So in this case, it's 180. So that means that from that green line, it needs to last for 180, or pi. So that would end this graph right here. Right there. That's my yellow. Okay, so that's pi. After pi over 4, that's pi away, or 180 degrees away from that. So then the next step is to do the amplitude. So the amplitude is how tall and how low it goes. This is 3. So from the equilibrium, it's 3 high, so 3 above that blue line, and 3 below that blue line. And then the last is you draw it. And you always have to make sure that you're looking to see if it's a negative out front. So I put in parentheses, will you flip it or not? So you got to recognize that. So in this case, there was no negative in front of the A, so that means this is not flipped. So since it's a sine graph, I'm going to look at my box. So it needs to fall within this box. So I'm going to draw my sine graph within that box. So sine starts in the middle, has a hill, crosses through the middle, has a valley, and then ends in the middle. So that is the final graph. So give 22 a try, and then play the video when you're done. So for 22, the amplitude is 2, the period is 360, The phase shift is negative pi or negative 180, and the vertical shift is negative 2. So the first thing I do is I draw my vertical shift, so it's negative 2, so that means the equilibrium will be down 2 from the axis, so right there. The next thing I do is the phase shift, so this is being shifted negative pi. So what that means is it's going to start over at negative pi. So then I do the period. So the period for this one is 360. So from negative pi, it needs to go over 360. So 360 is the same thing as 2 pi. So it would go all the way until regular pi, because that's 2 pi's from the negative pi. The next is the amplitude. So the amplitude is 2. So from the equilibrium, from the blue line, it's up 2 and down 2. So now I'm going to outline my box. So it needs to fit within there. I asked myself if it's flipped. It does not, because there's no negative out front. So now I can draw it. It is cosine. Cosine starts at the very top of the box, swoops down, and ends at the very top of the box. So that is my final product.